All right, today we are going to look at section 5.6. It's all about angle bisectors and perpendicular bisectors. Your objective is to use angle bisectors and perpendicular bisectors to find congruent line segments. Before we get into this any further, I want to review the definition for both of those. These are first semester definitions. You do not need to write them, but here they are. So, an angle bisector is a ray that divides an angle into two angles that are congruent. So, if I want to draw an angle bisector in that angle, where does it need to go? Right in the middle. Angle bisector cuts it in half. So, this angle is congruent to this angle. Any questions on what it means to be an angle bisector? Alright, the next definition we need to review is perpendicular bisector. It's a segment, ray, or line that is perpendicular to a segment at its midpoint. So, where is the midpoint? In the middle, I heard someone say. Good. So, if this is the midpoint, this segment is congruent to this segment. And it's perpendicular. What does it mean to be perpendicular? What kind of angle is formed when it's perpendicular? A right angle. So it'll go through at the midpoint. It'll be a right angle. So you will see a lot of both of these. About half the questions are angle bisectors. About half the questions are perpendicular bisectors. Remember, angle bisectors just cut the angle in half. Perpendicular bisectors cut the line segment in half, and they form right angles. Any questions on this? This is just a review, like I said. Alright, here's the new stuff. So take a second and write this down. This is the angle bisector theorem. Draw the diagram as well. We're going to add a little bit more to the diagram just to explain what's going on in that if-then statement. I'll give you a few minutes before we discuss. Alright, let me recap in case you missed it. So, if you have an angle bisector, these two angles are congruent. That's the definition of an angle bisector. This theorem says if you pick a point anywhere on that bisector, it's equidistant, which means it's the same distance to the outside of the angle. So this segment that I just drew is congruent to this segment right here. You might be saying, well, why is that true? Well, let me tell you. Anytime we measure distance, we use right angles. It's kind of like saying, like, you hear people say, like, the shortest distance between two places is a straight line. Same thing here. If I want to go from this point, the closest I can get to this line, you go at a right angle. That's just how you measure distance. So, if these are both right angles, these angles are congruent because it's an angle bisector. Do you see how this segment is the same in both triangles? So now we know these angles are congruent, these angles are congruent, these sides are congruent. So by angle, angle, side, these triangles are congruent. Everyone see what I'm saying? Following the argument? Okay, and then if the triangles are congruent, of course the corresponding parts are congruent. So if you want to prove the triangle is congruent each time and match up corresponding parts, you can. Or you can just remember that if you have an angle bisector, any point on that angle bisector is equidistant to the outsides. Any questions? Anyone need a little more time for writing? Alright, here we go. So, here's the next theorem. This is the perpendicular bisector theorem. It's going to be very similar to the one we just wrote down. But go ahead and spend a minute copying this down. Draw the diagram. Again, we'll add a little bit more to the diagram as we go. But this is enough to get you started. Alright, so the perpendicular bisector theorem, it's very, very similar. It basically says if you have a point on the perpendicular bisector, it is going to be the same distance to the endpoints on the segment. So this would be congruent to this. Of course, you're saying, well, why is that? Let me tell you. Anytime you have a perpendicular bisector, you know that the segments that are created are congruent. You know that these are both right angles. Right angles are all congruent. And this segment is in both triangles. Since it's in both triangles, that's a good example of side, angle, side, which makes the triangles congruent, which makes these corresponding parts congruent. Any questions on perpendicular bisector theorem?
Doesn't that make the entire triangle congruent?
Yeah, the triangles are congruent. Yep. Yeah, so you could even take it a step further and say, like, well, these angles are congruent, these angles are congruent. Yeah, all the corresponding parts are congruent. Questions? All right, we're going to look at a few examples. You don't need to write these in your notes. You can just sort of hang out and watch. But we are looking for yx. So in the first one, I have an angle bisector. So I know that y is the same distance away from z as it is to x. So if yz is 5.5, what's yx? 5.5. That's as easy as it gets, people. Questions? All right, same thing over here, except now we have the perpendicular bisector. So if I'm at point B, B is the same distance from A as it is to C. So what is BC? 13. Wonderful. What are your questions? All right, you did not need those in your notes. However, you do need these, so go ahead and copy these down. Diagrams at all? See if you can answer them on your own. If not, we'll go over them in about 3 minutes. We do have 8 examples today. So the quicker we can get through these, the quicker you can get your homework. You'll have to write 6 of them in your notes. So, right. There's one slide in there that I'll just let you guys watch on. But for now, just work on these 2. We'll go over them shortly. So if I am looking at this, I have an angle bisector. Those are supposed to be labeled as congruent, so go ahead and add that. This is an angle bisector. AD bisects BAC. And I'm looking for the length of BD. Anybody know?
15.
15. Yes, D is the same distance away from C as it is to B. So if CD is 15, BD is also 15. Good. Same sort of setup on number 2. The distance from L to M is 10. So what's the distance from L to K? Also 10. Good. They're equidistant, the same distance. What are your questions on these? These are both angle bisector problems. All right, next we're going to look at the perpendicular bisectors. Anybody need more time? Okay, couple minutes. Couple seconds more like it, minutes or All right, these are both similar types of problems in the way you find the answer. The setup's a little different, though. These are perpendicular bisectors now. So go ahead and sketch these in your notebooks. We'll go over them shortly. But in number 3, you're looking for FG. So this guy right here. Number 4, you're looking for PS. All right, so number 3 and 4, same sort of setup. We have perpendicular bisectors. So, what do I know about FG?
It's 12 degrees.
It's 12. Good. It is the same distance from G to F as it is G to H. So 12 and 12. Good. What'd you guys get for number 4?
18.
18. Very good. This is a cool problem. Do you see how this is a point on the perpendicular bisector Q? So Q's equidistant to P and R. And S is also on the same perpendicular bisector, so S is the same distance to P and R. Kind of cool, right? It's like 2 problems in one.
2 in 1.
Any questions?
It was a 2-for-1 sale.
That is correct. Are we good? All Alright, I want to look at these next two just on the board. You don't need to write these in your notes. You can just sort of put your pens down and relax for a second. Number 5, we have an angle bisector, BD. And then I have this point on the angle bisector, D. And then it goes to point C and to point E. What do I know about those two segments? They are congruent. Congruent means the same thing as equal. So these are going to be equal to one another. So I'm going to set up an equation. Oops, I forgot my x. I'm going to set up an equation. I'm going to solve for the x. Does anyone know how I solve that equation for x? That's one way you can do it. You can add 3 to both sides. So I would have 9x plus 3 equals 10x. Let's get our x's together next. What would I need to do?
Minus 9.
Yeah, subtract the 9x. 10x minus 9x is just 1x or x. So 3 equals x here. What are your questions? Alright, very similar problem on 6, but now I have a perpendicular bisector. So what do I know about AD and CD? They're congruent. If they're congruent, you can set them equal to figure out what x needs to be. How do I solve this for x? Divide by 12. So x equals 8. What are your questions? Alright, here's the last two that I want to do. In your notes, you can just write the equations. I think you guys have enough diagrams by now. You can sort of see the pattern. So let's just set the equations up together and solve. What's the equation I'm going to need on number 7?
21 equals 2x minus 5.
Good. 2x minus 5 equals 21, or you can do 21 equals 2x minus 5. It's the same thing. To solve this, what do I do?
Subtract 5 or add 5.
Add 5. Very good. So 2x equals 26. Then what?
5 to 26.
Very good. So I'm going to come up with x equals 13. What are your questions on that one? All right. Angle bisector on 8. What do I do on this one? Very good. Set them equal. X minus 8 equals 35. And then solve to get the x part by itself. How do I solve this? Add 8 to both sides. Good.
43.
Wonderful. All right, what questions do you guys have on this? All right, I'm going to give you your homework. You have the rest of class to work on it. If you get finished, throw it in the bin. If not, take it with you. We are doing a review tomorrow. This is the last section for this chapter that will be on your notebook check. So make sure you're getting your notes organized before then. And let me know if you have any questions.